Hello. In this session, we'll see another question on finding the adjoint of a matrix. So let's say we have a matrix of third order with elements 4, 6, 9, 6, 0, minus 2, 5, 8, minus 1. So we have to find the adjoint. So for this third order matrix, finding the adjoint will start with finding the minors and cofactors. And we know that minor, let's say minor Mij, can be found by the determinant formed by removing the ith row and jth column. For example, demonstrating the first one, M11 will be obtained by removing this row and this column. So it is going to be 0, minus 2, 8, minus 1. This will be 0 times of minus 1 and minus 8 times of minus 2, which is 16. Minor M12 will be obtained by removing the first row and second column. So this will be 6 minus 2, 5 minus 1. And this is 6 times of minus 1 minus 5 times of minus 2. So this will be minus 6 plus 10, which is equal to 4. Similarly, M13 will be the determinant 6, 0, 5, 8, which will be 6 times of 8, that is 48. M21, that is minor at the position of 2, 1, will be 6, 9, 8, minus 1. So this is minus 6 minus 8 times of minus 9. So this is 6 times of minus 1 minus 8 times of 9, which is minus 6 plus minus 72 equal to minus 78. M22 will be 4, 9, 5 minus 1. So this is minus 49. M23 will be 4, 6, 5, 8. 4 times of 8, that is 32, minus 6 times of 5, that is 30, will become 2. Minor 3, 1 will be 6, 9, 0, minus 2, and this is minus 12. M32 will be 4, 9, 6 minus 2. So this is minus 8 minus 54 equal to minus 62. M33 will be 4, 6, 6, 0. That is 4 times of 0 minus 6 times of 6 equal to minus 36. So let us see what will be the matrix of the minus, as we have found all the elements M11 to M33. 16, 4, 48, minus 78, minus 49, 2, minus 12, minus 62 and minus 36. So the matrix of minus will be all the elements, that is 16, 4, 48, minus 78, minus 49, 2, minus 12, minus 62 and minus 36. Now we know that for the odd positions, cofactor will be negative of it, and for the even positions, the minor and cofactor are same. So we can see that this position A12, this position A21, A23 and A32 are all odd positions for which the cofactor will be negative of it. So matrix of the cofactor can be formed here itself. So the minor of cofactor will be 16 minus of 4, 48 minus of minus 78 minus 49 minus of 2 minus 12 minus of minus 62 and minus 36. And this is 16 minus 4, 48, 78 minus 49 minus 2 minus 12, 62 and minus 36. So this is the matrix of cofactors. Now adjoint A will be simply transpose of the cofactor matrix. So this will be 16 minus 4, 48, 78 minus 49 minus 2 minus 12, 62 minus 36 whole transpose. So transpose is obtained by interchanging the rows and columns, and this will be, the first row will be the first column 16 minus 4, 48. The second row will be 78 minus 49 minus 2, and third row as third column will be minus 12, 62 and minus 36. So this is the adjoint A we were trying to find. So the first thing we did was finding the minors of all the elements, then forming the matrix of the cofactors, and the transpose of this gives the adjoint A. Thank you.